Thank you, everyone. So I think the teams before us, they have already set a good stage for this business problem. So we are going to talk about how we did our imputation-based pooling technique to come up with the predictions. Hi, everyone. My name is Rashnal, and today I have with me Anish and Scott. And we are from University of North Carolina. We are master students in statistics and operational research and information science. Uh, and thank you everyone actually for giving us this opportunity to present our finding and really appreciate that. And we assure you that as we go through our presentation, we'll take you through each and every step that we followed. And we strongly believe that our technique will definitely help Syngenta in early detection of varieties that needs to be commercialized. So moving on to the business problem. So as we all know, this business problem was pretty complicated. We had around 16,000 varieties, and out of those 16,000 varieties, we had close to 38 varieties as part of our prediction set. And our main objective was to recommend close to around 15%, that is not more than 5 varieties out of these 38 varieties to be commercialized. And we need to make sure that the varieties that we recommend for commercialization, they should perform really well in the commercial market. So in other words, we had to make sure that we minimize our type 1 error as much as possible. Another thing was we had to make sure that these variety show more than 1 million bags sold as part of our prediction for 2016. So since this was a complex problem, there were many challenges associated with that. So that brings me to our challenges. So as I said before, so we had like 16,000 varieties, and they were tested across 151 different locations. There were multiple experiments, multiple repetitions, and there were many, so this data was around from 6 years worth of data. And we had in total around 250,000 records. So the main challenge was to how to understand this data and how to transform it to a form that can be used for analysis or prediction. So that was our biggest challenge. The second thing was, out of all these varieties that we had, we only had 33 varieties which had actual bags sold information. So we had a very small data set to build our model and validate our model against our prediction technique. So the data set was very small. Finally, the prediction set that we had 38 varieties, and these 38 varieties were tested in 88 different locations. And there was minimum overlap between modeling set, which were tested in 140 locations, and the prediction set. So we treated our modeling set for our training purpose, and we treated locations as our features. So the challenge was to train and validate our model on a different feature set and to test our model on a completely different feature set. So that was the biggest challenge. So the question for us was how to come up with a strategy and how to move forward. So we came up with a cohesive methodology. We basically divided our problem into different categories. So the first was to concentrate on understanding the data, reshaping it, transforming into a form that can be analyzed. And after that, once we had our data, to fill the missing values with applying techniques such as imputation, and with those imputed data, build our prediction models and come up with the predictions, and finally validate our prediction to make sure that they are consistent. And once we were confident that our prediction were consistent, we moved ahead to predictions and recommendation. So now we'll take you through the first step, which was data aggregation, and Anish will tell you about how we did that.
Good afternoon, Revert, ladies and gentlemen. So now to talk you through the data shaping process. One of the biggest challenges, the initial challenges we had was with the raw data. So the raw data given to us was not something that we could immediately use for any modeling. So the first challenge was actually to reshape this data so that we could derive any insights from it. So before I proceed further, I would like to thank our sponsors Tableau for giving us a year's version of Tableau that really helped us with the data shaping process. So what we did was, for the data shaping, first of all, we relativized the yield data that was given to us so that we could factor out the temporal and spatial factors to make them comparable. After relativizing yield, we came up with a table which shows relativized yield by variety and location. The table that you see to the right of the screen there is the data that we reshaped. And this was done using Tableau. One of the advantages of this was we could actually get what the relativized yield was based on variety for a specific location. So after reshaping this data, we categorized the data sets into two parts. Basically, the ones which have higher relative maturity and ones with lower relative maturity. This actually helped us build different prediction models based on what the relative maturity of each variety was. And moving ahead, so the only big problem with the matrix that we came up was there was a lot of missing data. Some of the locations did not have the yield data associated with it. So the big challenge was actually to fill out all these missing columns. So to actually deal with this problem, we use something called the mice package in R, which is called multiple imputations chained equations, to actually estimate what that missing data should be. So what the mice package does is it does multiple passes of regression to actually estimate what that missing value is going to be. However, the problem was, since this is only these are all imputations, there's a Monte Carlo algorithm that was embedded into this package. So we didn't rely on just one imputation, but we relied on like several imputations. We did about like we created about 20 imputed data sets. We did this, so the data sets that we imputed, we picked out 44 out of the 151 possible locations as possible features that could actually help us predict what the backsold could be for the varieties with high relative maturity, and we picked out 49 out of the 151 locations for the ones with lower relative maturity. With this, we went about doing the imputations, and we created about 20 imputed data sets for the higher RM varieties and for the lower RM varieties as well. So with these imputations, we were able to fill out the sparse matrix that we created, and that actually helped us with the model building process. So to move ahead, so the next step was, now we had the imputed data sets, we were interested in actually the actual model building process. So we had 20 imputed data sets and 44 possible predictors for the higher RM varieties. So our first step was to use lasso regression to actually do a first pass feature selection. After we did that was useful because we had 44 predictors. The problem was we couldn't use all the 44 predictors because we felt that we would run into problems of overfitting. So we used Lasso to do a first pass feature selection, and then we did a Box-Cox transformation on all the features that we had, because this helped to reduce heteroscedasticity and stabilize the variance that was there in the data. After doing that, we used the Bayesian information criterion to further narrow down on the possible set of predictors on the possible set of features that we could use to predict what the ultimate sales of all the varieties was going to be. We did that for both the data sets that we created, the ones with the higher relative maturity and for the ones with the lower relative maturity. After creating these models, we felt that we should also validate these models to ensure that they are relatively consistent in their predictions. So to talk more about our next strategy, which was cross-validation, I'll hand it over to Rashnel.
Thank you, Anish. Once we have our modeling strategy and we came up with this technique, we wanted to make sure that whatever model we are building, they are pretty consistent and they produce significant results. So we used a commonly used technique called leave one out cross-validation. Since our data set was very small, so like we had 20 data set, but each data set had only 20 varieties with the actual backsold information. So we used this technique where we had like 20 iteration per imputed data set. And for each iteration, we held out one set as our test data. We trained our model on the remaining 19 varieties, and we followed the same technique that Anish talked about, like going through Lasso and all those things. And we repeated that for all our 20 data sets, and we came up with our 400 models. So in this 400 models, we had like 20 varieties, and for each variety, we had around 20 predicted values. We repeated the same thing for lower relative maturity varieties, and it gave us around 460 models. So because in our lower relative maturity model, we had around 23 varieties. So it gave us around 460 models. So with that, the results were really significant. So there were high variance in low relative maturity, but if you see in high relative maturity, so this chart is from high relative maturity. So if you see, there are many varieties where the predicted and the actual values were pretty close. So for certain varieties, there were less than 5% deviation between predicted and actual varieties. And on the overall, there were less than 36% error. So this actually really motivated us that we were able to get consistent and significant results using our modeling technique. So which further takes us to our predictions and recommendations, and Scott is going to take you through that. Thank you.
Thank you, Rashnil. Okay, so Anish talked to you about the fact that we built 20 models for the low relative maturity and 20 models for the high relative maturity. So what we did was we actually took this and made 20 predictions for each variety. And what we did was we pooled these predictions. We took the predictions and took the mean and the standard deviation across all the 20 imputed data sets for the high relative maturity and for the low relative maturity. And to net it out, what we would like to recommend are 3 varieties for commercialization. And in doing this, I want to first say that this has to be done in the context of Syngenta's current product portfolio. So essentially, we're recommending the 3 models you see there. One has a relative maturity of 3, the other 2.8, the other 3.1. All 3 of them had predicted sales well over $1 million. And we understand Syngenta wanted to minimize type 1 errors, so we were conservative in that. Also, all 3 varieties came from our more accurate high relative maturity model. So we felt more comfortable recommending those. After we got the call that said that we were invited to the final presentation, we decided to take another look at it. We really felt that the recommendations we gave Syngenta were not enough. It was a very narrow range of relative maturities. So what we wanted to do was we wanted to provide Syngenta with potentially other recommendations. So what we did was we used a completely different technique to estimate the yield, to predict the yields. We used elastic net regression, which essentially blends lasso and ridge penalization. Lasso and ridge is specifically designed for situations where you have very few observations and a lot of features to select from. We minimize the error to weight this more towards ridge than lasso. And we're very happy to find out that the results were consistent with our original estimation, at least from the point of view of the order. In other words, all the top varieties recommended by our first model are also recommended by this model. So as an updated recommendation, we have 2 additional varieties to recommend. One with a relative maturity of 2, which might be more suitable for customers with shorter growing seasons, and one with relative maturity 3.9, which would probably be more suitable for customers with longer growing seasons. And lastly, I want to point out that the predictions with elastic net are biased, so we kept our original predictions. But again, subject to Syngenta's market needs, their current product portfolio, we recommend those 2 varieties as stretch varieties for potential commercialization. So with that, I'd like to turn it over to you for questions.